We're now at lesson 3.5, and we are talking today about solving quadratic equations by using the completing the square method. So there's really two objectives, as you can see today. I want to show you how to solve equations by using what is known as the square root property, and then we're going to look at actually using completing the square. So let's just jump right into some examples that hopefully line up pretty closely to your homework problems. So 14 to 25, I just wrote the instructions from your book for you. Given this quadratic equation, how would we solve it by using the square root property? Well, it's important to recognize that the left side of this equation represents what is known as a perfect square trinomial. The reason why it is classified as a perfect square trinomial is because it meets certain conditions. Number one, there are perfect square roots at the beginning and at the end. These terms have perfect square roots. So the square root of x squared is x. The square root of 36 is 6. Okay, so that's condition number one. You must have perfect square root terms, or terms that have perfect square roots, at the beginning and at the end of the trinomial. Not only that, that could be true, but it's still not a perfect square trinomial. Now we have to multiply these red terms together, these square roots. And if we multiply them together, of course, we would get 6x. And now think of that times 2, or doubled. And as it turns out, we get the middle term of our trinomial, the blue. So this does qualify because it meets all of those criteria. It qualifies as a perfect square trinomial. Now, why is that important? Well, because perfect square trinomials are very easy to factor. The factored form of that left side of the equation is given here in red. You just write the square root of the first and the last, put a bracket or parentheses around both of those. The sign is determined by whatever is in front of the x term, and then you just raise that quantity to the second power, and you will have the factored form. Now, why is that important? Well, because if we can get to this point, solving is really pretty easy, because all I'm going to do at this point is the square root of both sides, because the square root essentially will remove that exponent 2 and create x plus 6 on the left side. But don't forget, if you do the square root of the left side of the equation, you must also do the right side. And also, very important that you not forget, when you do the square root of both sides of an equation, you need to include plus minus for the number. Okay, so we are down to x plus 6 is equal to plus minus the square root of 6. So you're definitely going to use a calculator for this assignment, because the second sentence in the instructions says to round to the nearest hundredth if necessary. Well, the square root of 6, if you grab your calculator, the square root of 6 is a decimal, and rounded it would be 2.45. Okay, now we'll just go over here and continue. So instead of showing the square root of 6, we're going to show it as plus minus 2.45. So now remember, for a quadratic, we're going to come up with two solutions. One of them will be found by solving the positive, x plus 6 is equal to positive 2.45, and the other solution will be found by solving for the negative, x plus 6 equals negative 2.45. Okay, so over here we're going to subtract 6. So if you need to grab your calculator, 2.45 minus 6, and that's negative 3.55. Okay, over here we're going to subtract 6, but we start with negative 2.45 minus 6, and that's negative 8.45. And those are our two solutions. And that is an example of the square root property. All right, let's take a look at another one. It's a good idea to first check and make sure you do have a perfect square trinomial. So let's see, the square root of 9x squared is 3x, the square root of 25 is 5, so we definitely have perfect square root terms, but we need to keep going to test. So let's multiply these terms together and we get 15x. When we double that, or multiply by 2, sure enough, we do get 30x. So this passes the test of being a perfect square trinomial. So we factor it very easily. We just put parentheses, squared, and then whatever sign is in front of the x term goes in between. Okay, now we're ready to use the square root property. So square root of both sides. That gives me 3x plus 5 on the left. On the right, I get plus minus the square root of 11, so let's just go ahead and figure out with our calculator what the square root of 11 is, rounded, and that's 3.32. So this is going to be plus minus 3.32. Okay, so our two solutions, if you have to break it up into two equations, that is great. One of our solutions will come out of this equation, and the other solution will come out of the negative number equation. Okay, so you can grab your calculator. This is going to be two steps. We need to subtract 5 first. So 3.32 minus 5. So we'll just go ahead and show the result of each step. 3x is equal to negative 1.68, and now we're going to divide by 3 to get to our solution, and that's negative 0.56. Okay, over here we're going to subtract 5, and that should be negative 8.32. And now we're going to divide by 3. Divided by 3 is negative 2.77. Okay, and those represent our two solutions. Alright, so let's try another one. Alright, let's see if we have a perfect square trinomial. We know that this has a perfect square root. If we do the square root of 6.25, we get 2.5. Okay, but the true test is, can we multiply these together and double it to come up with the middle? And the answer is yes, because if I multiply negative 2.5 times x and then times 2, I'm going to get negative 5x. Alright, so the red represents the factoring of the left side of this equation. Okay, so to solve for x, I'm just going to do the square root of both sides. And the square root of 4, of course, is 2 plus minus. And now I just treat this like it's two separate equations. I'm going to solve x minus 2.5 is equal to positive 2, and x minus 2.5 is equal to negative 2. X is going to be positive 4.5. X is going to be 0.5. Okay, so I hope that helps you understand solving by using the square root method. Okay, now we're going to move into a different type of problem for your homework, problems 26 through 43. The issue here is it's not quite as easy because they didn't give us an equation that already contains a perfect square trinomial. As you can probably tell just by looking, we have negative 8 here, and it doesn't have a perfect square root. So that's a problem. It has to be a perfect square root number in order for us to factor this as a perfect square trinomial. So what we're going to do with the completing the square method is we're going to force this into becoming a perfect square trinomial. Okay, here's what I mean. The first thing I'm going to do is move this number to the right side of the equation so that I can create space. I'm going to create space for a number that will represent a perfect square root number. And it will create a perfect square trinomial on the left side of this equation, so we can go back to doing what we did before. We can use the square root property. Okay, so here's how you're going to come up with that missing number that we say is the number that completes the square. Do you remember what the factoring of a perfect square trinomial always looks like? Notice it here. Notice it here. 3x plus 5 squared was the factoring. X plus 6 squared was the factoring. So let's just go ahead and set up what the factoring should look like. And it should be the square root of x squared. Bring down this sign. And the way you get this number inside the parentheses, it's always found the same way. Easy to remember. You always divide whatever's in front of x. We call this the linear coefficient. You always divide that number by 2. 2 divided by 2 is 1. All right. So think about this. This bottom part represents the factoring for some perfect square trinomial. And the way you find out what this missing term is, it's very simple. Just take my number 1 that I have in parentheses and square it. And if you square 1, you still get 1. So the process is, to get this number in the parentheses, you just divide the linear coefficient by 2. Always divide by 2. Okay? To get the number that completes the square, you take the number in parentheses and raise it to the second power. And that tells you also that since you added 1 to the left side of this equation, you must also add 1 to the right to make the equation balance. Okay, so now we're in familiar territory because we're going to use that square root property, which says to do the square root of both sides. The square root of the left side would just give me x plus 1. The square root of the right side would give me plus minus 3. Alright, so the way I'm going to get my two answers, I'm going to solve basically two equations. One for the positive 3, one for the negative 3. So my two solutions are x is 2 and x is negative 4. Okay, that is an example of completing the square. Okay, let's try another one. I do have perfect square root terms here and here, but if we write down the square roots, x and 3, multiply them together, I get 3x times 2, I get 6x. Well, to be a perfect square trinomial, this is supposed to be minus 6x. It's not, so this cannot be a perfect square trinomial. So let's just make it so that it becomes a perfect square trinomial. So we're going to move the 9 out of the way. It's obviously not a perfect square trinomial with 9, but we are going to make it become one with a different number. So I'm going to move the 9 to the right side of the equation using subtraction. And I've got this space here for the number that will complete the square, or make it become a perfect square trinomial. So just think of the factoring. The square root of x squared minus, because the sign just comes down. And then once again, you always divide what's in front of x by 2. 4 divided by 2 is 2. Okay? Now, to know what the number is that completes the square, you just take the number that you came up with in the parentheses and square it. Negative 2 squared or positive 2 squared, it really doesn't matter. It's going to be the same result. It's going to be positive 4. And then since you added 4 to the left side, you need to add 4 also to the right. And when you combine these on the right side, you end up with negative 5. Alright, so now we're back to the square root property, and when we do the square root of both sides, we end up with something familiar with a couple of lessons ago. We're going to be doing the square root of a negative number, so we're going to need the number I in order to simplify this. All right, so this would be the radical form. But since we're basically going to stay consistent with our instructions and leave this in decimal form rounded to the hundredths, so let's go ahead and find the square root of 5. The square root of 5 rounded is 2.24. So instead of leaving it like this, I'm going to change it to the decimal equivalent. Instead of the square root of 5 times I, we're going to say plus minus 2.24 I. Okay, either way is okay. Sometimes we'll leave our answer in simplified radical form. Today we're going to leave our answer in rounded decimal form. Okay, so to get my final answer, I'm going to add 2, or you could think of it like this. We're going to solve x minus 2 equals the positive, and we're also going to solve x minus 2 equals the negative. Okay, so adding 2 to both sides, and you got to be careful here because this is really like unlike terms. It is very much using the principle of unlike terms. You cannot put these together and say that it's 4.24i. This is an example of what we looked at a few days ago. This is a complex number. A complex number is in the form a, which is the real number part, plus b, I. The real number part followed by plus or minus the imaginary number part. Okay, so the same kind of deal over here, except over here we're going to have 2 minus 2.24 I. So I just wanted to emphasize to you that you cannot put these together like you would like terms. You need to express your answer in this case as a complex number, a plus bi. All right, letter C is a little different because you notice we have a coefficient greater than 1 for x squared, or really we could say other than 1. Could have been negative. So my first move here is to make the coefficient for x squared become 1. In order for that to happen, I'm going to need to divide by 2, which is that coefficient. And I'm showing this because whatever you end up dividing by needs to be divided into every term. Okay? If this had been 5x squared, I'll be dividing everything by 5. After dividing by 2, I end up with this equation. Okay, now I can complete the square. This is not already a perfect square trinomial, so let's prepare it so that it becomes 1. We'll look for that number, move the constant -6 over as +6, and now let's search for that number that goes in the blank that would create for us a perfect square trinomial. Okay, square root of x squared, bring down the sign. 3 divided by 2, you could write 3 over 2, or you could write the decimal form, 1.5. Now in this blank, we're going to do 1.5 squared. Okay, so grab your calculator if you need it, and that's 2.25. And we're going to add that to both sides of the equation, and so the right side becomes 8.25. Okay, the square root property says take the square root of both sides of this equation, plus minus, and let's just go ahead and use our calculator and find the square root of 8.25. Square root of 8.25 is 2.87 plus minus, and now our solutions will come from solving basically 2 equations. We're going to solve for the positive 2.87, and then we're going to solve for the negative. Alright, so over here we're going to do 2.87 minus 1.5. That's 1.37. Over here we're going to do negative 1.5 minus 2.87, or the other way around, negative 2.87 minus 1.5, negative 4.37. And those represent our two solutions. Okay, very good. All right, let's try this one. Once again, I notice that there's a coefficient not 1 in front of x squared, so just think division all the way across, dividing by 2. Now I get x squared. I can leave this as 3 over 2 x. And remember, this is not a perfect square trinomial, so we're just going to be adding 3 over 2 to both sides. I think I'll just leave this one in fraction form, so you can get a taste of both ways, fraction and decimal. Okay, so let's think about the factoring, what it would look like. Square root of x squared. Bring down the minus. Now what happens when you divide 3 over 2 by 2? 3 over 2 divided by 2 is the same thing as 3 over 2 times 1/2, and that's 3/4. Or if you're using decimals, you could think of 0.75. Okay, now remember how we get this number in the blank? We came up with 3/4 or negative 3/4, however you want to think of it, and now let's square that. If you square a fraction, you basically square both parts, the numerator and the denominator. So this is going to be 9/16. All right, and now we just think of common denominators in terms of sixteenths. This would be 24/16 because multiplying by 8 would give me 16. Then I had to multiply the top also by 8, and that's 24. So I'll show it like this, and then we'll put them together. Now that we have a common denominator, we can add those together, and we'll get 33/16. All right, very good. Okay, square root of both sides. Okay, when you do the square root of a fraction, it's like doing the square root of each part separately. So we got the square root of 33 on top over 4, which is the square root of 16. Okay, so let's just go ahead, since we've got to change these to decimal, and let's find the square root of 33 divided by 4, and looks like that's 1.44. Just go ahead and change this, since we're going to be plugging into our calculator anyway. I'll just go ahead and change this to 0.75. Okay, so hopefully you saw how we just did the square root of 33 and then divide that decimal by 4. And so our two answers again come from solving two equations. One for the positive 1.44 and one for the negative. Okay, so in your calculator, you're going to be adding 0.75, and you get 2.19. Over here, we're going to start with negative 1.44 and add 0.75, and that's negative 0.69. And those are your two answers for letter D. Okay, this is our last example. I've got a few examples because this is a pretty important part of what we're doing. I wish the book gave you more practice with this, but basically the idea here on your last two problems of the assignment is to take a standard form quadratic equation, which is what you see in blue for letter A. That's called standard form. And we're going to convert it into what is known as vertex form. And I've given you an example, a general principle, definition if you will, of what standard form looks like using variables. And the great thing about vertex form, the great thing about vertex form that you see here in green is that when you're in this form, the numbers that sit in this spot that I have underlined here, the H number, and this other number that I've identified as K, those literally represent the vertex. So unlike standard form where we have to find the vertex by doing the opposite of b over 2a, plug that number back in, do a lot of calculation, with vertex form you can see the vertex just by looking at the equation. So here's how completing the square works with changing standard form to vertex form. Remember what the factoring of a perfect square trinomial looks like? Essentially it looks like this, a binomial squared. Okay, so let's think about what we did earlier when we completed the square. We did the square root of this first term. We brought down this sign. And remember this important step, we always divide the linear coefficient, in this case 6, by 2, and we got 3. Okay, so to change from standard form, which is in blue, to vertex form in red, this is an important next step. Whatever this number in parentheses is that is squared, 3 squared, I just want you to go up to standard form and subtract it. You always subtract this number squared. Okay, and you can tell we're almost in vertex form already. The a in our vertex form is really 1. It's invisible. So to get the rest of our vertex form, we just need to put those two constants together, and we got it. That's all there is to it. This is an important step. Just remember, you're always subtracting from standard form. So this is the vertex form, and then the further directions say to identify the vertex. Alright, so the vertex, remember, the H number in this form is the vertex. Well, remember what we talked about with horizontal translations, which is really what this is. This is a shift of the parent function 3 units to the right. Because if you look at our green vertex form, to make this become plus, then that means H, which represents the horizontal movement, must have been -3, right? If you subtract -3, don't you get +3? So the vertex, the x-coordinate, is going to be -3. Got to be careful there again because it's always the opposite of the way it looks. The y-coordinate of the vertex, in other words identified as k, is whatever is outside the parentheses, and you do not do the opposite there. It's straightforward. So thinking of our translation, this will be taking the parent and moving it 3 units to the left and 14 units down from the origin. Okay, so that's the complete answer for 3a. So let's practice a couple more of those. Okay, so standard form, let's see what it looks like in vertex form. In the parentheses, you just do the square root of x, bring down the sign, and then don't forget to divide by 2. 2 squared is 4. Always subtract it. Just think of going up to your standard form and subtracting from the end, and now put those constants together. 6 minus 4 is 2. So the red, erase too much. The red represents the vertex form, and then the directions say find the vertex. So the x-coordinate will be -2. The y-coordinate would be +2. Okay, let's try one more. Alright, just set up your parentheses squared, square root of x squared. Bring down whatever sign that is. Divide by 2. 6 divided by 2 is 3. Now think, -3 squared is 9. You always subtract. Notice every time. We found the number in parentheses squared and we subtracted it from the standard form every time. So if you practice it, it gets a lot easier. 3 minus 9 is -6. Alright, so once again we have the red is the vertex form, and now let's write down the vertex. The x-coordinate of the vertex is 3. The y-coordinate of the vertex is -6. So that's what you're going to do on, I gave you 3 examples. You actually only have 2. We'll come back and practice this some more. And that's your assignment. So hopefully these notes are going to help you, but if you get stuck, there should be a homework help video as well. So check that out. You can always email me with questions, and work hard on it, and I'll see you next time.